Question number 16. Okay, another level I must say, 1 multiplied by 2 multiplied by 3 plus 2, 3, 2 into 3 into 4 plus 3 into 4 into 5 up to 10 terms. Now, this is a really common pattern, and if you are a math student, you might have actually solved these kind of questions. It's an NCRT question. So, how to approach this question? All you have to do is step 1 is to find the nth term of this series. What is the nth term of this series? So, for example, here the first term here, 1 multiplied by 2 multiplied by 3, right? And there is this one pattern that you can notice every time you hover around each and every series element of series. You'll see that here this is n. This is the first term of the series. This is the second term. This is the third. So how about if I say the nth term would be, according to this, n multiplied by, okay, n multiplied by n plus 1 multiplied by n plus 2. Right? Think about it. First term. This is also for non-math students. So make sure that this is inside your mind. N multiplied. You have to find a pattern and kind of create a function for it in the form of variables. N multiplied by n plus 1 multiplied by n plus 2. Take the first element of the series. 1 multiplied by 2 multiplied by 3. Works. So we have the nth term. Earlier before also we were given the nth term and we were asked to find the sum of n terms, right? In the previous question. Similarly, we just have to do that. So this is n, but then this is a lot more complex. Now what you have to do is open the bracket. N square plus 2 plus 3n multiplied by n. Okay, I write it down for understanding. Now, like before, okay, the handwriting goes wild at the end, apparently. But yeah, this is what happens. And now you just have to solve using the formula given before. Or I'll also help you with this. Okay? I know you space it pretty less. You have to remember. The way, let's see. Yeah. Remember, I think n cube plus this was the case. What is the sum of cubes of first n natural numbers? N multiplied by n plus 1 by 2 whole square plus 2 multiplied by n multiplied by n plus 1 by 2 plus 1 by 6 plus 3 multiplied by n plus 1 by 2. We'll take n into n plus 1 by 2 outside. So n square plus n by 2. I just open this. Plus 2, 4 and plus 2 by 3 plus 3. And then substitute the values. Now it's pretty simple, simplified. So we already have this with us 10 terms. Substitute 10 in place of n. We get 5 multiplied by 11, 55 multiplied by 100 plus 10, 55 plus 3 plus 42 by 14, right? 42 by 3, 14. So 17, 72 multiplied by 55. 72, 55, 370, 370, 4070 is the answer. You've done it by yourself, just check this out. Great, 16 complete. How awesome is that? Question number 17. This is in the NCERT class 11 textbook, and I've also seen this in a couple of JEE modules, so it's very important in the entrance point of view, and you might expect this question coming in for the IPMAT paper 2 someday or the other. So what is so special about this question? Let's see, it's not an AP, not a JP, but then you've done enough logical reasoning questions to accidentally kind of find a difference between the adjacent numbers. 11, 5, 6, 19, 11, 8, 29, 19, 10, 12. What's so special? Yeah, this is an AP. Two conclusions. One, this is an interesting question. Two, we have to do some kind of a subtraction in order to solve this problem. Let's see how it's done. Sum S is equal to 5 plus 11 plus 19 plus AN. Similarly, this is 5, by the way, okay? Don't get yourself confused. How about if I write 5 over here? It's still right? So 19 comes under 11 comes under 19, 5 comes under 11, AN minus 1 comes under AN, and we have AN over here. Now I'm asking you to find the difference between these two. S minus S, 0, 5 plus 11 minus 5, 6, 8. Remember the difference that we found before, till AN minus 1, so we just have a close bracket. This is 0 minus AN. We can bring AN to the other side, so AN is equal to 5 plus sum of n minus 1 terms of this AP. So n minus 1 by 2 2a, 12 plus n minus 2 multiplied by 4 multiplied by 2, sorry. Now the rest of the part you can do it by yourself, because what next is, in the previous question too, what we had done was we did sigma AN, right, to find this sum. So if we have the nth term, we can just do the formula, execute the those three formulae to figure out this sum. That will be used here too. You just have to open the brackets to basic math and kind of create a proper function, which I've already solved. You just have to add 12 and minus 4 here and there and get the answer. Now after that, use the formula and you'll end up getting the final answer. You can refer to the NCERT for the answer. Yeah, that will be it. Great. Question 17 complete. Question number 18. So find the sum of the series 1 multiplied by 2 plus 2 multiplied by 2 square plus 3 multiplied by 2 cube, and goes on and on and on. So these kind of questions, let's try finding the general term and let's see if we can find the answer out of that. 2 multiplied by, so the general term here, by looking at the pattern, you'll find that it has to be n multiplied by 2 to the power n, right? N here is 1. If you take the first term, 1 multiplied by 2 to the power 1, or second term, 2 multiplied by 2 to the power 2. So this is the formula, but then we don't have enough resources or idea about actually trying to utilize this. So besides, there's no enough time to ponder a lot about this. Instead, we can try something else. How about we do an entrance way of answering this by manipulating the options and trying to figure out, manipulating the luxury of having options. Let's see. So here, if you look at the sum, the final term is 100 multiplied by 2 to the power 100. And if you add that with the first two terms, here this is equal to 2. First term is 2, second term is 4, 8. So 2 plus 8 is 10. So this should obviously be greater than 100 multiplied by 2 to the power 100 plus 10. But then if you look at the sum, the options, this comes in, and obviously these two are lesser than this. So we can conclude that B and D are not going to be the answers to the question. Instead, it's going to be A or C. So that's one positive that we've got. Great. Now we have to find A and C. We have to figure out which one would be the answer, right? Now for that, we know that we can think about the fact that sum might just have this, the value of the sum can be expressed using a general formula. For example, 1 plus 3 plus 5 till n terms can be expressed as n square, and this is a real equation. This is a real formula. Sum of odd terms is equal to n square. Sum of first n odd terms would be equal to n square. Now, similar to that, this sum as a general formula, similar to that, this sum might also have a general formula. That's what I'm trying to say. So let's see if we can find a general formula to this. Let's take option A. Now, looking in option A, we can express A as, okay, there are 100 terms in this AP, right? In this series, right? So option A can be expressed as n. Instead of 100, we're using n multiplied by 2 to the power n plus 1. Clear? It's clear, right? Now let's take the first term, A. It is equal to 2. Now how about if I execute this over here? 1 multiplied by 2 to the power 1. It works. Sum of the first term is 2. Over here also 2. But usually don't take first terms, like I mentioned before. Try not to take risks with the first term, or take number 1 for assuming anything. Try 2 or 3. So try a little bit bigger numbers, like 2 or 3. 2 or 3 are not big numbers, but bigger than 1. 2. Let's take 2 terms then. 4, 8. 8 plus 2, 10. So S2 is 10. And let's see if this general formula works. 2 multiplied by, it works. No, it doesn't work. Yeah, and if you look at it, plus 2 also exists. So that might be the reason why option 1 works. Okay, so either way, 8, 16, 18. So that means option A is not the answer. Now, what if I take option C? Let's see, option C. Option C can be expressed as n minus 1 multiplied by 2 to the power n plus 1, right? So we know that S2 is equal to 2 plus 8, 10. Let's see if it works over here. Let's substitute 2 in this equation. N minus 1 is 1 in this case, because n is equal to 2. 1 multiplied by 2 to the power. Don't forget this, because there is a plus 2 over here. 1 multiplied by 2 to the power 3 plus 2, 10. It works. So option C is the answer. I hope this is clear. This is one way of approaching this question. You easily get the answer quickly. Fine. Question 8 complete. Now 19. Question 19. Now this is going to be the most difficult question so far that we've answered, and question 20 is also easier than question 19. This came for last year's IPMAT Indore paper, and I still remember I didn't get the answer to this question, and I was actually literally multiplying and adding 1 multiplied by 3, 3 plus 35 plus 99 plus 160, 168 or something. And it goes till one point, and then I obviously stopped because 10 terms of the series was difficult to find. But then it's not available on the internet too, this answer, for some reason. So I found this by myself, and I was definitely excited to get the question, this answer. I'll explain how it's done. So firstly, usually when you see this odd numbers, right, all of these are odd numbers, what do we do? 2n minus 1. So for those who don't know, 2n minus 1 is used to express the nth odd number, you can say. Similarly, 2n is for even numbers, right? So I did something like this firstly, 2n plus 1, and we can summate them. That's what I expected. But then what happens is this equation works for the case 1 multiplied by 3 plus 3 multiplied by 5 plus 5 multiplied by 7. And obviously this is different from this. So 1 multiplied by 3 plus 5 multiplied by 7 plus 9 multiplied by 11, right? So these two are different. This is my first approach. The second approach should always be trying to find the values of each and every element in the series. 1 multiplied by 3 is 3. 5 into 7, 35. 9 into 11, 99. 13 into 15 would be 175. Sorry, 195. Yeah. And it goes on till 10 terms. Now, I want you to pause a minute to try finding a pattern to this. What could be so special? The thing is, this is n square minus 1. N could be any natural number, so we've not defined what could be n. Let's see. Look at it. 4 minus 1 is 3. 36 minus 1 is 35. 100 minus 1 is 99. 196 minus 1 is 195. So square of a number minus 1. Right? Let's see squares of which numbers. 2 square minus 1. 6 square minus 1. 10 square minus 1. 14 square minus 1. Something special? Yeah, it is an AP, right? So we're going to find the nth term of this particular series using this concept. How to do this? We can definitely find the nth term of an AP, a plus n minus 1 into d. We're going to use that concept. So nth term of an AP, let's see. Nth term is equal to a plus n minus 1 into d. A here is 2. 2 plus n minus 1 multiplied by d here is 4. 2 plus 4n minus 4. 4n minus 2. This is the nth term of the AP. But that's not the nth term for this series. Nth term for the series would be square of this number minus 1. So that would be 4n minus 2, the whole square minus 1. That would be an. 4n minus 2, the whole square minus 1. 4n minus 2 whole square minus 1 is an. You can simplify that, obviously. Now summate them to find the sum, right? So 16 multiplied by sigma n square. 16 multiplied by n plus 1, 2n plus 1 by 6 minus 16 multiplied by n plus 1 by 2 plus 3n. Note that point. That is important. Don't forget that. At times that would be the theta. And substitute n here. you'll get the answer then. Let's see. 20, 21, 21 by 6 would be 7 by 2. 56. 56 minus 56 multiplied by 110 minus 8. 55 multiplied by 16. So 616, 0 minus 880 plus 60. This is the answer. Find the answer and you can drop it in the chat box or whatever. So this quest is complete. Question 19 complete. This was, I think, a really difficult question. If you are able to solve this question, you just do awesome. Question number 20. The final question, and we're done with this session. Okay, it is given that the sequence xn satisfies x1 is equal to 0, xn plus 1. Again, we're just simply going to substitute and find out whether we can find an answer. Let's see. x1 is equal to 0. Now, how about x2? What would that be? x2 is equal to x1 plus 1 plus 2 multiplied by root 1 plus xn. Xn is 0, so 0 plus 1 plus 2 multiplied by 1. What would that be? 1 plus 2, 3. So this is also a question that appeared in the essay section of IPMAT Indore 2021. Now x3 would be 3 plus 1 plus 2 root 3 plus 1. 4 plus 8. I'm sorry, 4 plus 4, 8. x4 would be 8 plus 1 plus 2 root 8 plus 1. 9 plus 2 root 3. 6, 15. Now, if you look at the question, if you try analyzing the pattern, you'll see that there is a really evident idea or pattern. 1 square minus 1 is 0. 2 square minus 1 is 3. 3 square minus 1 is 8. 4 square minus 1 is 15. That's the idea. So x31 would be 31 square minus 1. So 31 square is 961 minus 1, 960. That's it. So we're done with 20 questions, and almost all the concepts were cleared in this session. And yes, 20 questions, enough practice and enough theory. And try practicing more questions. Try giving the tests. We do have a Telegram group, right? So be consistent there and participate in the quizzes. Enjoy the process, and we'll meet someday, definitely. That will be it from my side. All the best for not just IPMAT, for your future, and that will be goodbye.